Thanks. This venue, people always say this, but I really mean it. This venue is super awesome. So I walked in and like a really nice job getting this organized. Extremely happy to be here. And as I said, thanks for having me. I think streams are awesome. So much so that is anybody else disappointed that the streams talk wasn't in the awesome JS section? Like, I thought that was a little ridiculous. Perhaps it's because I put computer science in the title and we all kind of go back and think, oh, that's boring and that's not awesome enough. But just saying that maybe I'll work harder to get into awesome mode next time. Let's do a little bit of poll and see where everybody's at. How many people write JavaScript? Nice. So you guys made it to the right place. How many people, and this isn't just JavaScript only question, how many people write for the backend, the server or the full stack or what have you? Okay, so keep them up and then you can put them down if you're not writing much Node.js. So you're writing on the backend, but you're not writing a lot of Node.js. Okay, so the people whose hands are up are writing Node.js on the backend. All right, that's cool, that's fine. You don't have to do it professionally either. Like you can just have written 4 lines of it and that counts. Like, I'm not much beyond that, honestly, guys, come on. All right, so seriously though, about me is, one of the things I really like about Node is when I like Steven was just up here and we have we'll go on Stack Overflow and be like, Node is performant. And then you're like, well, what does that mean? And then you have to dig in and look and learn so much more about this thing that you were doing than maybe you ever even cared about. But you do care, and it's cool, because we're all stewards of our craft, and we like what we do, and then when we know more, we're better. And I think, at least for me, Node has just really, in spades, provided that opportunity for me. Just thinking about my system at a much more critical level than perhaps I do when you're just gem install, right? Well, I mean, yeah. And in particular, streams and the complexity of streams and what a stream is doing really just drove me to want to talk about, what is a stream and how does it relate to Node and what we're doing and why do we even care about it? So we don't really even have to go into JavaScript. We don't even really have to go into much of the application layer to start to think about streams. And TCP, if we look at just the definition on Wikipedia, talks about accepting data from a data stream and passing that along. And then the other side is true too, is receiving data from a data stream. Stephen, again, talked about a bit about libuv right now. And the basic I/O tool in libuv is the stream. So when we think about Node.js and we think about networking and the web and connections and if I can go on a tangent, how awesome is http.createServer? The most insanely fun thing to do when you're just, I'm going to make a web server. Okay, cool, did it. And then all of the way that we're doing system I/O through libuv, this is all just based on streams. Not all of it's based on streams, but for the sake of the discussion. And just as a quick tangible example of how this can be, I guess, powerful if we wanted to, I have a 10 gigabyte Breaking Bad file, and if for some strange reason I wanted to create a web server and send that to myself, because that's the kind of stuff I do is just create server and send things to myself. I couldn't do that by buffering that file. So if I did fs read file Breaking Bad and tried to send it over a server, it's just not going to, Node won't even let me do it. Node or libuv or whatever won't let that even happen. If I stream it though, and I do fs.createReadStream of my Breaking Bad file, even though it's 10 gigabytes, I'm able to curl this and get this saved to my desktop. So how does that work? Well, in Node parlance, or when we talk about sending data at different rates and receiving data and communicating, we use this term backpressure. So me and my system reading a 10 gigabyte file off disk virtually always is going to be faster than the rate at which I can send it over the web. That's a pretty easy statement to make. And so because of backpressure, I'm able to read just enough of that file until I reach my limit, send it out, and when that is now cleared from my buffer, or I have extra space, I can now continue to send more of the file. And this is how I'm able to send a 10 gigabyte file. And fundamentally, that's the streams in a contrived nutshell. But how? What is that level when I talk about, oh, I can't send anymore? And this is really, this piece right here, when we talk about streams, and when I listen, I think more to people talking about streams, there's like, oh, and then the high watermark, there's just like this high watermark. And I wanted to kind of think about, oh man, like what is the high watermark? Like that first is a funny name for me, but what this does is this allows our stream to check how big its buffer is. And if it's above that, it'll say to the producer of the information, can you hold on a sec? I need to wait until I've drained. So in fake JavaScript, this is, I think most of this would work, except for FN's not real. When we create a stream, we're able to give it its own high watermark, or the default is 16 kilobytes. So if that reaches above 16 kilobytes and then we try and write, it'll return false. And that's what this is right here. The buffer becomes larger than the high watermark. And the reason this is relevant is because we are piping all of our streams together. So we've got a web server that receives a request that then loads up a file and then sends a response. So the response is asking for data. The file is producing data. But when the response says, I can't write any more data right now, I've reached my high watermark, I've returned false, we'll pause and we'll exert that back pressure. And when it's cleared, we'll resume, and everything's great. And the fact that this works is kind of amazing, and it feels magical when you do it. But when we say things like, Node is good for mobile, fundamentally, this is what we're saying. Is no longer is it some contrived example about, oh, I'm trying to send a Breaking Bad file to myself. That is admittedly ridiculous. What we're talking about is the consumer of that data or the producer might be slower than what I can handle. And in particular, with mobile connections and mobile devices, that oftentimes is slower than what your server can produce, how your server can produce that data. So when I'm reading a file, I can control that. I can say like, okay, wait, send some more of the data. But I had this nagging question when I thought about streams. It was like, well, what if I can't? What if it's not my file system read stream, but I'm actually downloading the new copy of Windows, and I want to, for whatever reason, do some type of transform and send that on. Like, Microsoft is pushing data at me. How do I talk to them? The more I looked at this, and if everyone in this room knows the answer to it, I think that's a good thing. But for me, it was like a little bit of an ignorant question. It was kind of like missing the forest for the trees in many ways, because I was like thinking about like my application, and I've got like a file, a readable stream, and then I can't control this one. But if I step back a little bit and think about it, again, looking at the TCP and the definition of how it handles flow control, it's an essential part of how the internet works. So again, maybe I was the only one that kind of thought about this, but when I would talk to like colleagues and mentors of mine, I'd be like, does the kernel just receive data from Microsoft in this example, and the packets get dropped on the floor, and like sometimes no one even knew the answer? And then I just thought about it, and I'm like, well, wait a minute, like the internet does that, like every day, all the time. There's just congestion, and it manages it, and TCP is able to negotiate the back and forth. So for me, that's really helpful when I'm thinking about streams, because I can start to wrap my head around this idea of like, oh, okay, like there's some built-in mechanisms, and I program for the web, and I love HTTP create server, and that's all streams, and that's all built on back pressure. man, I should be like this streaming stuff is phenomenal. And so when you're writing streams, this is a little bit of an outlandish statement, but you almost feel like you're programming how the internet works, right? You're like programming the same style. And that sounds kind of crazy, but it follows fundamentally with how that is going. So I guess philosophically, that's kind of terrible in terms of wrapping your head around it or looking at it. But a better example than these big files or downloading something from Microsoft might be in like my work. So I work in advertising technology, and like many of us here, our jobs and what we do, we may have like partners or customers that need access to data. So in ad tech, we're working with customers and partners often to provide impressions or engagement metrics and sending that over to them. So we need to be able to look up in our analytics system what happened today, what happened yesterday, and provide, whether it be a JSON dump or a CSV file or what have you. And so there's a variety of ways that we can do this, like using a delayed job, loading it, caching it, providing access to your customers on some set interval. All are pretty common ways. But another way we could think about doing this is perhaps streaming it. One of the cool things about this example, though, is it kind of took this streaming concept and like really like made me like be like, okay, this is awesome, and this is why streams are fantastic. Because I did it on the airplane on the way here, and go-go internet it's the most fantastic and awful thing at the exact same time. Like when it works, like you don't even realize you're on an airplane, which I guess is sad because we're all just like computing. But when it doesn't work, it's like the Louis C.K. bit, and you're like freaking out like, this is bullshit. But it is pretty bad. It cuts in and out. But it's such a good test of how streams work. Like I was like, this is so amazing that I'm doing this right now. And I also did this on an EC2 micro instance, which is such a bad machine. Like it's like you just like deploy up to it, but like it's just like not good. And so like I'm doing two things now. I've got a constraint on bandwidth, like I'm over Montana, and then my computer is not good. Like it's just a terrible, totally CPU bound, not a lot of space. I think everything's like shared on it. I don't even know. I just know it's like terrible, and it's awesome to just like throw stuff at it, like run tests on it. So I have two ways that I wanted to send the data out. So I've simplified this again to just try and fit it on the slide, but I created a server, and then in the callback, for the streaming example, looked up the DB, looked up today, the record was like 65,000 records. Transformed them into a CSV, so it basically just took the keys as the headers and then put the values for the rows. Gzipped it and sent it out. The only thing that isn't even Node Core there is the CSV part, and it's like not that many lines of code anyway. So like, again, it's just really exciting when we think about programming Node and how it just like has these built-in capabilities for like the exact thing I wanted. And I can plug them all together and do something interesting. So I'm getting all these records from a database, streaming them into a CSV builder, gzipping it to save on file, like whatever, and then sending the response out. In the buffered example, so we'll look at the buffered example. And this is like your classic like complaint of Node.js is like HTTP handler, get all the database from today, make a CSV, gzip, and like all these nested callbacks. It looks really ugly. Like totally side point that I'll probably get like trolled for is like, how pretty does that look, right? It's like just pipe, 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 pipe. I need to put error handlers in there, but it's cool. Like you get kind of addicted to this like streaming interface, which I will talk about, so be careful. So this buffering example is actually going to look up all the records, and I've got all of them now, and then I want to make a CSV from all of those, and then I want to gzip up all of that data, and then send it out. That's like how I would be shocked if most of us didn't learn to program that way. Like that would make a lot of sense. But the stream worked, and like I don't even need to give you numbers. Like the buffer just didn't work. Like it would start to respond and just end. And then meanwhile, the streaming one, I'm sitting on the airplane. I mean, it was slow. Like you wouldn't. It's not the best experience you've ever seen, but you just see these records kind of coming. I was curling it, so my terminal is just like slowly like printing the standard out, like ding, ding, ding. And meanwhile, it's working. In terms of some actual numbers, throughout both of them, as the request was happening, it was using the buffering one was using about 5 times more memory. So its heap used was about 5 times more than the streaming example. But the fact that that was even possible in the streaming, again, on an airplane, on an EC2 micro instance, I think lends itself really well to discussing, how streams can, work within these constraints that aren't just necessarily programming languages, but like my bandwidth was terrible and my hardware wasn't that great. So, right, Node.js is for planes. That's kind of the headline, right? No, Node.js is for mobile. Everybody knows that. I actually take some issue with that because it seems like marketing speak. Like everyone's hot on mobile, and like I'm running again on these like cloud servers that are the furthest thing away from mobile. And like by and large, I think most of us are probably doing something similar when we're writing Node. You can't market this, but because of streams, Node.js is really for diverse network speeds. So when we're fast, and when we need to throttle, we can throttle. And why is that the case? Because all the things are streams. We talked about towards the beginning, TCP thinks about how it communicates with streams of data. And when we think about our file system I/O, writing files, reading files, streaming that in and out. And DB is kind of, I think, combination of the two of those, right? Is we're talking to a database through a combination of those streaming systems. And Node allows us to do all of that. And it's super awesome. Like I said, it's awesome JS, even though we're in the afternoon here. But there's some caution. So the first thing I did after I did the airplane is I went on loader.io and I did a loader test and like wanted to see like, oh, this is great. I can run 1 trillion requests on an EC2 micro instance. I have just solved all of the problems for every company ever. Right? Like you start to think like I was saying, like be careful before you get too crazy about streams. Like, no. There is a cost to attaching all of these event handlers and to having your system keeping track and bookkeeping for all of the streams that we're piping. So like at 1,000 requests, like this is pretty tangential, but like the loader.io like didn't even get my responses because the response.end event or like method hadn't even been called yet because they just go so quick, and then this server is like sitting there waiting forever. And as well, it just took so much processing power, and like Steven can talk to that much more eloquently than I can. I would love to talk about it more after this and continue talking about streams. The other piece that in preparing for this talk that I think is cautionary is streams, I think, still are pretty complex. And talking with people that are just, technically I admire, and professionally I just think the world of, I mean, even they were, when we would talk about streams, there's lots of questions. When we look at the Node side in particular, there's some documentation, what is this actually telling me to do? I don't know if anybody's banged their head against the wall, next, and high watermark, and what happened. That stuff actually all came out in March, and then the docs came out late July, and so it was crazy for all these months. For me in particular, I was I had no idea that things had really even changed that drastically, and then you go and look up streams again in the API docs, and it's wait, what? And so I think as we come out of that, it gets pretty exciting. So in terms of what's next, based on looking at streams from this holistic point, if you are writing a lot of streams, continue to do so. I think I kind of took a a slight jab at the docs, but I do think that the new interface and how we kind of base class streams with readable, writable, transform, pass-through, that stuff is really, really nice. I think they did a really nice job. I think it can be polished, but overall, that automatic handling of back pressure and the high watermark is really nice to see, and to see what's coming up and how we'll all use that in userland is really great. If you're kind of confused about what I just talked about, maybe because I'm confusing, or because you want to learn more, I don't know, there's really great materials out there. So I wanted to try my best to focus a little bit more on the high watermark and some of that stuff today. But if you are looking for a little bit of a walkthrough, go to nodeschool.io. There's Stream Adventure. Substack and Max Ogden did that. And it is so far beyond how I could have explained and like hands-on live coded done streams. And so it's a really nice way to go through and see what are streams about, how am I using them, how are they utilized, how can I compose streams together, what's a transform stream, what's a readable, what's a writable. In that same vein, Substack, the Stream Master, has a stream handbook, which kind of describes, again, the fundamentals of streams and talking about it. So just Google Stream Handbook. That'll be the first hit. And I wanted to give a shout out to some of the work that people are doing to help explain streams and push them forward. WhatWeG has a stream spec for the browser. And, remember when I was talking about how pretty it looked with my DB example? I was like, oh, that's really great. Like, the same is true if you had like an AJAX request and you could just kind of handle that across. And so a specification around that, I think, would be nice. Again, and you guys know me now that I like these contrived examples. Like, there's also this weird world in which you may download like a movie file, and as you're downloading it, send it off into a child or like a web worker. So I'm talking client side now. Send it off into a web worker and use some streams, and then the video that's playing in your browser is actually being like changed in some way out in this web worker, and it's all like piped together through streams. So keep an eye on that. Take a look at it. Additionally, they've had the opportunity to kind of start now versus three and a half years ago. And so whereas we look at the Node world and it's a bit more evolutionary, it's interesting to see their take on streams now, having been able to see what's going on in the Node world. Thorsten Lawrence also has a project called StreamViz, which does probably the best job I've ever seen about showing these high watermarks and what's happening with your streams. So if you Google either the WhatWeG streams or TH Lawrence StreamViz, you will find those projects and can really be helpful in terms of streaming. So although the cautionary tale, I love the way that Node lets us work with the web. I love the way that streams embrace what we do on the web, and keep calm and stream as kind of the Zen closing piece. So thanks a lot, guys.